Writing down some characteristics of the atom, the average atom. So the atom is the simplest form of matter. And because it is the simplest form of matter, I'm jumping down to the last bullet here, an atom cannot be physically or chemically decomposed. We cannot break it down into smaller chunks of matter. So we cannot break it down. So I probably should put the word not break down into smaller matter. That's the simplest that exists around us naturally. Now, a group of identical atoms is referred to as an element. The identity of an atom is only based on the number of protons in the nucleus. And a very important idea that will help us in a lot of the future content is the word atom. If we see a structure and it's described as an atom, atoms are electrically neutral. So we want to get that idea memorized. So now, every atom. So when we're thinking about this, think about this as the atom. This is the whole body. And like the human body, our whole body is made up of smaller body organs and parts. So the atom's body has subatomic particles, so these would be like the body parts. And the individual body parts can't exist stably outside the structure of the body. So like our heart does not live on its own. It needs to be connected into our body and working as a whole unit. So that's the same thing with our subatomic particles, protons, electrons, and neutrons. Each subatomic particle has its purpose inside the atom structure, just like our individual body parts. They each have a job. So the proton, the symbol that we tend to use to represent it is a lowercase p with a superscript of a plus sign, so P for proton, and that gives us a clue about the charge. Every proton carries a +1 charge. The protons, they are located in the atom's nucleus, and every proton contributes a mass of 1 AMU. Moving to the neutron. So the other body part, neutron, its symbol is N to the 0. So N for neutron, and that superscript of a 0 tells us about its charge. It is neutral. So value of 0, you can write the word neutral. The neutron's location are in the nucleus along with the protons. So they are in the nucleus along with the protons. And a neutron, like a proton, each individual neutron contributes a mass of 1 AMU to the structure. The electron, its symbol, lowercase e, with a superscript of a minus sign. So the E for electron, and that superscript gives us a clue about its charge. Each electron contributes a -1 charge to the structure. Electrons are not in the nucleus like the proton and neutron, so the most technically correct answer is they are found in orbitals, which we will talk about a little bit later in this chapter, but these orbitals are regions outside the nucleus. Okay? Now the electron's mass, is a fraction of an AMU. So each electron contributes a fraction of 1 over 1840 AMUs. So the electron's mass is really insignificant, and if we were to just simplify it, we would say, well, an electron basically contributes 0 AMUs to the structure. It would take 1,840 electrons to contribute 1 AMU to the structure of the atom. Okay, now purposes. What is the job of this subatomic particle? So for the proton, number one purpose is it supplies the identity of the atom. It also contributes mass. It also contributes charge. It contributes to the properties that we see, so like physical properties. And it also determines the element order on the periodic table. So I'm going to put PT order. The neutrons, those body parts, let's list some ideas of what they contribute to the structure. So each neutron, okay, contributes mass to the structure. They don't contribute charge, but they help to determine the isotope, which is an important word we will get to. The neutrons will also help determine nuclear stability. Meaning, is that atom radioactive or not? So I'll write down radioactivity. That's kind of a scary word. And then on to the electrons. So electrons, they may be very, very small when it comes to terms of mass, but very, very important. So the electrons, they definitely contribute charge to the structure. They don't really affect the mass in a meaningful way, but electrons determine the chemical properties of an atom. They determine the number of bonds that an atom is able to form. They are also what is responsible for producing light, and it is their action that produces electricity. So electrons are pretty important, and in the realms of everyday chemistry, the electrons are probably the subatomic particle we pay the most attention to. Now, I threw out that term AMU, or atomic mass unit. So this is a unit that scientists developed to represent the masses of individual atoms, molecules, particle, or subatomic particle, because their masses are insignificant compared to an everyday gram. So 1 AMU relates to a gram. So 1 AMU is about 1.66 times 10 to the minus 24 grams. So an AMU is significantly smaller than a gram. Now, I said scientists designed this unit of mass to relate to atoms, molecules, and their parts. So the AMU is specifically based on the carbon-12, so the carbon-12 atom. And they define it that 1 AMU is equal to 1/12 of the C12 atom. That's how scientists defined it.